Hello friends, welcome back to Rising Mathematics. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 3 Ring Theory. Question is, prove that any homomorphism of a field is either an isomorphism or it takes each element into 0. Proof. Let F is any field and R is some ring. Now let us consider a map phi from field F to R as a homomorphism. Now we know that kernel of homomorphism is an ideal, therefore we will have here kernel phi will be ideal of field F. Now since F is a field and we know that only ideals of field F are trivial ideals, therefore kernel phi will be either singleton 0 or kernel phi will be either field F. Now let us consider kernel phi is singleton 0. Here we will show that phi is an isomorphism. For this we will show phi is 1-to-1 mapping. Thus, suppose phi of x is equal to phi of y for some elements xy in field F. This implies phi of x minus phi of y is equal to 0r, where 0r is the additive identity of ring R, which can be written as phi of x minus y is equal to 0r. Now since we have phi of x minus y is equal to 0r, the element x minus y will be a member of kernel phi, and kernel phi is singleton 0, so we have x minus y is equal to 0 and therefore x equal to y, and this shows that the map phi is 1, 1. Therefore when kernel phi is singleton 0, phi will be a 1-to-1 mapping and thus phi is an isomorphism. Next, if we consider kernel phi is field F, then for all elements A in field F, we have phi of A is equal to 0 and thus phi takes each element of field F to 0, and hence from these two cases we can conclude that any homomorphism of a field F is either an isomorphism or it takes each element of field F into 0, and this proves our result.